I'm Eric Norton. I'm an AI officer at Zyphra. We are doing AGI foundation models and agents targeting AGI.
Hi, good afternoon, everyone. I'm Duncan Ng. I'm the Vice President of Solutions Engineering at Vultr. Very happy to have this discussion with this team here. Vultr provides infrastructure as a service, both GPU and CPU globally. Really an offering that, from a compliance and privacy perspective, is differentiating from the other offerings out there.
Hello, everyone. My name is Oktay Azarmanesh. I'm a principal AI architect at Snowflake, and mostly focused on conversational assistants, agents, helping our customers build on agentic solutions.
So let's open up with a bit of reflection, because it's hard to believe it's only been a year in this industry. Last year at the end of 2024, entering 2025, it's hard to believe there was no such thing as reasoning models, really. Like OpenAI had just introduced O1, the first reasoning model. Not everyone was even using them, way before DeepSeek and all that. So why don't we reflect on what you've seen, respectively, as the most significant changes over the past 12 months or so, and of course we'll end later on what we predict for next year.
All right, I think there was a big move from regular LLMs towards reasoning models and then towards agents. It was a big change over the last year, also towards open source.
Try holding the mic a little closer.
Open source,
yeah. Open
source reasoning, agents. And I think these are the ingredients also needed for moving forward with this agent in the future. Mm.
I think, like Eric said, it's really how do you tie multiple thoughts and workloads together. No longer is asking a single question. No longer am I trying to answer, this one specific problem. How do I build a workflow to really handle that? One of the actual other things that we've seen probably in the last quarter and a half is a little bit of a turn, so a trillion parameter model is no longer novel. We've actually seen a turn kind of going the other way as well, where instead of building a kind of model that can do everything, much more of a focus towards models that are much more specific, much more kind of domain expertise to really start delivering business values for that particular vertical, that particular use case, as opposed to trying to, harness a semi-truck to do, what you can do with a pickup truck.
I mean, I would go a little further than like just 12 months. I would go about 2 years ago, and looking at it from the lens of the Snowflake, it's just the speed with which we have kind of come in the last 2 years is just astonishing. But reflecting to the last year, 2024 was when we started talking about agents. Probably it meant something different than what we have now. But it is just interesting how it came to maturity now, and kind of based on the conversations we see this year, that kind of can lead us to where we will be next year, but it's really hard to know.
And so in the prep discussion, Oktay, you mentioned some interesting stats, that Snowflake is seeing, enterprise deployments, and then Duncan, I'll come to you as well, and if you can remember something interesting that you want to talk about as well, Eric, and then we'll get on to the next topic.
Yeah, sure. So I can go first. So last year, the other thing that was the trend was mostly just POCs, demos, things that not like customers were building, but they weren't really deploying to production. And then this year, that has completely changed. And that kind of means that customers now actually see value from building those. And so just the number I was giving, like in some of the features and some of the parts of the generative AI products that we have, we've seen tenfold, like 1,000% growth quarter over quarter. So that's just amazing.
I think for our side, from the enterprise adoption, I would kind of, describe your vantage point at Snowflake kind of halfway between do-it-yourself and kind of the token-only model. And that's definitely what we've seen, is that still for folks that are looking to do this kind of full stack on their own is still relatively early in the game on the enterprise side. Absolutely generative AI startups, kind of AI ML-focused organizations are very clearly down that path. But your classic Fortune 500 company is still kind of, they're past the ideation phase. They're now kind of figuring out how do we do this at scale at margins that actually make us revenue, or makes the productivity gain more than the cost of doing this. So starting to see that integration happening, having a chance to talk with a large number of different intersection points are seeing that enterprise adoption finally picking up where they fully now understand, with open source models, with, being able to get infrastructure, the data center space, how do they take that proprietary data and really generate, new insights, novel insights for data that they own already, and how do they get their organization to see some true returns on that?
I think we are in a very exciting time. I think we're in the early stage of enterprise agents, and for some use cases are easier to implement, some are harder, but I think the efficiency will improve everywhere on the model side that we are working on, as well as in the infrastructure side. The models become smarter with reasoning, and we are working very hard to try to innovate on the cutting edge to get as much intelligence as possible in a model for compute. And and also then of course for enterprises to optimize for future workloads. So I think it's an enormous momentum we are in right now. It's so much fun working in this industry.
Speaking of the fun, I want to get your opinion on a particular sort of next trend. For the last year, we've seen what I call the seasons of AI. So we saw the beginning of 2025, really end of 24 is the reasoning season. Then we saw the rise of agents, particularly coding agents. I don't even have to have a show of hands here. I'm sure we all were using Cursor and especially Claude Code this year. I found reinforcement learning because we kind of closed the year, a season of reinforcement learning, and now continual learning. So what do you think will, persist into next year? What perhaps can you predict, in terms of these model trends that will surprise us or be new next year?
Absolutely, we are working also very hard on reinforcement learning. This is kind of the hot topic right now, also for getting better reasoning agents and better models. It's one of the post-training, one of the key ingredients. And continuous learning is still kind of open. We are talking about, I think since 2020, we were talking about continuous learning, but it's still not really solved yet. So you can try to solve it on system level to some degree, but there's still something we think is missing, which needs to be invented by someone. Hopefully by us, but we'll see.
And Duncan, you were talking about some small model trends. Again, Sid alluded to that earlier on today. Share more.
Absolutely. I think for us, it's really a case of where is this going to deliver value for the users at the end of the day? Are they going to have to invest, tens of millions of dollars, or are they going to be able to find ways to build specific use cases? I was talking to someone, who is using a very large model to do a fairly small kind of business use case. And I think what's going to happen is that people will start to better understand their tools. I use the kind of super tanker, semi-truck, pickup truck kind of model. Yes, I can move in a super tanker, but that's not going to get anywhere close to where I live. It's, a whole mess, probably these days with the amount of junk I have in my house, semi-truck is probably the right size. I'm not moving out of my college apartment anymore, so pickup truck doesn't really cut it. So it's really finding the right tool. So kind of as the model sizes, so model size kind of just bigger is better, I think is finally a realization that people are making. They're better understanding how to tune those models to deliver the specific business use case so that they can drop some of the costs that, and we've seen costs kind of spiral in some interesting ways in the last 24 hours where that's a case where, there will be a better correlation between the use case, the cost, and the outcomes.
I mean, customers are not only becoming aware of, wary of cost, but the bigger the better model is also breaking because of the latency. They don't want for simple questions to take 1 minute to get a response. They want something faster, and that requires smaller models, fine-tuned models, and that's a trend we see as well. And I would say also on the trend of small AI startups and Fortune 500s, we definitely see a lot of big use cases in Fortune 500 companies going to production and actually getting a lot of values, and not 10-20% improvements, but orders of magnitude efficiency improvements using these features.
So I think hopefully, we're not going to talk about the AI bubble here because I think it's become a cliche topic, but we're getting some really strong data points, again, from enterprise data, enterprise infrastructure, enterprise models, that there's hard, real demand here. It's not logical demand at all. So speaking about, who's going to pay for all this and what we're going to be paying, let's talk about some of the pricing trends that, wow, was the reaction I had as well to OpenAI's announcement for their new premium model. So as this market is maturing and segmenting, we're definitely seeing more than one kind of pricing trend. And on the one end, open models, which we'll talk about, Eric, can be priced at below $1 per million input and output tokens, well into the just 10 cents, 15 cents. But we saw this one premium number announced. I don't know if you caught it yet. For output tokens in particular, the GPT 5.2 Pro model, just so I get it right, is priced at $168 per million output tokens, which is a kind of a shocking number, but it just shows that the era of the premium token is a thing. So what are our thoughts to follow up our last sort of discussion around pricing trends and segmentation and the variety of models enterprises are going to be looking for going forward?
The model efficiency went up already a lot, so models are much cheaper to deploy because models improved, infrastructure improved, data improved. So everything is improving as this keeps going. We are working on actually small and medium open source models, so people can use it from our side directly, or they can download it and use it for themselves. The nice thing with open source, you can really customize it for agent applications. You can keep it sovereign on-prem or in different countries, and so that's a big benefit of open source. And all this will help keeping the price lower.
I really view this almost as a game theory kind of finance question. This is a case where you have a dominant market player who's choosing to flex pricing power, and it's really a case where the question is, will they have overstepped their bounds? The example that I have about this is a customer of theirs, a top 10 energy company in the world, where we engaged their team on a pretty long conversation. And, we wanted to better understand, how they were using it, what they were doing with it. And the metaphor that I essentially came up with, they were the kid that got handed $20 and went to the arcade. What do you do at the arcade? You put your $20 in, you get tokens out, you take your tokens, I'm gonna play Pac-Man, I'm gonna play Star Wars, I'm gonna age myself, that's what you're gonna do with it. At the end of the day, you had a good afternoon, had some fun, you don't have $20 anymore, and you don't know how to build a Pac-Man machine. So there are absolutely enterprises that are still in that phase. They have not taken those next maturing steps, and I think this is indicative of this particular market player trying to leverage that position. I think what this will force to do, as we've seen in many occurrences previously, is that people then all of a sudden go and look for alternatives. When all of a sudden the price is now so expensive, you're going to have to show some market improvement against your competitors. And when people look and they go, it's marginally better, is it worth the step change in pricing? Do they actually have that type of pricing control in the market? I think that will be the interesting thing that we'll see, probably by the end of Q1 of this year.
I was going to also play the devil's advocate and say actually $160 per million token for someone who gets real value from that 1 million token is actually cheap. Like 3 years ago, if you said for 1 million tokens you would get these amazing outputs automatically, just like looks magic, $160 is cheap. But I think there are 3 different dimensions that you can take a look at. Like what kind of value you're getting from that. But then the future trends is major improvements on getting the price down on the hardware, but also like breakthrough ways of training these models that would bring down the price of training and inference on the models that will really drive these use cases.
So are we seeing any of these breakthroughs right now with regards to, let's just quickly talk about training and then we'll get to inference. I think you're in a really good position, Eric, to see whether we can expect some breakthroughs on training costs, training times.
All right, I think there's a constant improvement on the training side. So we are training focused right now because we're developing these models. Better data helps a lot. Model architecture innovation. So we have an architecture team trying out new things. We have a different intention, different. We're going beyond transformers. So today, all these models are transformer-based, invented by folks at Google 2017. But these things are now scaled up for LLMs. And then reasoning came and all these things. And we are also looking into those components, but also in details to improve both training time and inference time. So we are actually right now, we do research on NVIDIA and we do all the pre-training on AMD because that helps us on the cost side. And you can scale up and create better models.
Yeah, that's very revealing, actually. It's really good to hear stories like that. Duncan?
I think on our side, we're breaking the hegemony of, one of the two offerings that are out there consumed at scale. Had a meeting with an autonomous driving company this morning, and the feedback that we got in their evaluations that they're doing currently is that AMD is within the margin of error of the state-of-the-art models for kind of 8X card systems. So all of a sudden, it's no longer a case where there's one option that's, quote unquote, clearly more capable. There is absolutely now a second option that can drive significant benefits from a price perspective, significant benefits from a speed to delivery perspective, as well as all of the rest of the ecosystems. I think all of us have been in this long enough to understand competition's a good thing. When there's an 800-pound gorilla who just gets to flex, that doesn't help anybody else but that 800-pound gorilla. And there's, I think, finally an opportunity where we are seeing some significant capabilities and significant capacity that's going to be available as an option. No longer are you going to have to speak to just one organization to be able to get the compute that you need at scale in the long run. So I think competition, we've seen announcements, from other providers as well in terms of what they're looking to do in next calendar year. So I think it'll just be very innovative to drive a truly competitive landscape for compute.
I mean, Eric and Duncan have better perspectives here than me because I come from the data side and how the enterprise are building products on it. But my perspective is, I think making improvements by 5, 10, 20% year over year probably won't get us to where we want to go with AI. And the multiple-fold improvements will come in breakthrough technologies, as I mentioned. And probably this will be my bold predictions for next year, but I'll elaborate more when we get there.
So we have a bit of time. I want to add, an element here. So we're covering one misconception with regards to the fact that it's not just big models only. It's not just NVIDIA only. What are some of the other misconceptions I think we should share with the audience here that we've learned over the past 2-3 years that might become apparent or obvious next year? Just starting with misconceptions on the model side. You already hinted at some, Eric. What are some misconceptions that are going to be, whether it's around algorithms, whether it's around memory usage, KV cache usage, certainly whether it's around large or small deployments?
I mean, I can maybe go first on the application side. I see customers building applications on AI, and the building phase, they expect it to be as magical as the models themselves and applications themselves. But the building phase actually takes some work. There's still some effort needed to iterate over certain things. I mean, that part is becoming more and more automated too. Like just every month we have like different tools that just eliminate hours of work that was required the previous months and does that automatically. But I think still we require some kind of work to get it to good accuracy.
Right, that's a good point. So it's easy to prototype and demo something with ChatGPT with some wrapper around it and wow, have a good effect. But to really productize it, it's a long. It depends on the use case. So sometimes a little bit easier, sometimes way much harder than expected. So this one misconception: people easily underestimate the effort to really productize all these things. The other thing is on the model side. Often people think, ChatGPT or Gemini, this is just one big model. Even those things these are all systems, right? There's routers to large and small models and memory. So you do innovation on model level, but you also do innovate on the application level where you add all these components. And people think it's one LLM. It's a system. Everything are systems, even today. And agents are even more complicated. Yeah.
And I would state the obvious by saying that the 20/80 rule here still applies. Like to get to 80% is really easy accuracy-wise. But then the last 20%, getting closer to 100%, just takes a lot of effort.
So again, before we close off here, I want to add another fun, controversial thing. I disagree with Ilya Sutskever, right? So Ilya was on Dwarkesh's podcast a week or two ago talking about the fact that, in his esteemed opinion, we're back into the era of research for AI. We're not so much in the era of engineering. I disagree, to the point we just made earlier on. Bringing these apps and agents to market is a lot of work. It's a lot of engineering work. We don't necessarily, New science is always great, but there's so much engineering work to do. What do you think? Do you agree or disagree with Ilya?
I think the one approach that I've talked about, think about this is, I actually kind of agree with Ilya, is that we are seeing such new breakthroughs, not just every quarter, every day. And the way that the breakthroughs are presented right now, it's not, an IEEE paper. It's not a presentation at an industry conference. It's literally academic work that's getting done. And, just the number of people that are in PhD programs doing this, and let's not just say someone who's joined in the last year or two, someone who's in year 4, 5, and 6 of their PhDs. It is very much an academically kind of oriented scenario right now, where those of us who are trying to build these things are literally consuming academic work at a faster pace than we've ever had to do it before. This is absolutely not a case where there's templates you can start with A, everyone will get to their own B and C, but there is no template to kind of do that at scale currently. Literally, that template is changing every month, every 2 months, every 3 months to deploy something. So I would actually pretty strongly agree with Ilya's comments on that.
I agree with Ilya on this. I disagree with him on something else that he said maybe last year around AGI and how we're achieving that. And regarding these models as these magical things, that they are magical, but they're still like state machines kind of predicting what's next based on the training data. And we kind of sometimes forget that. We have to go to the fundamentals. And on the fact that I agree with him and with Duncan, is that the next breakthrough, my prediction is, will come from academia. And it will probably rely on some old paper from 20 years ago and finding a new application for it. Because of the new things that the models and the hardware is enabling us, we can go back to the previous papers and take a look in a fresh light on to them and bring that to now.
Maybe a tiebreaker here, Eric?
Yeah, so I think it's similar to other revolutions we had earlier with the steam engines. When granted, it didn't take off right away, right? There's some mixture of research and deployments until people figured it out how to use it properly. And same here. It's a mix of things, and it will trickle in. It will change the world very soon over the next years.
To use a physical model to describe this, 30 years ago, a bunch of fiber got put into the ground. A bunch of businesses went bankrupt, but all of a sudden, what that put the foundation for is what we all take for granted these days. I was sitting there in the corner, I'm like, I have terrible phone signal in here, jumped on Wi-Fi, did all the stuff I needed to do. When the material costs come so far down, whether it's through, model layer, whether it's through hardware layers, all of a sudden things that were never imagined before, all of a sudden become possible, as opposed to, that's going to cost us $100 billion, $10 billion, $1 billion, $100 million. As you take these orders of magnitudes down, what people will choose to do with that are going to be things that we don't even have in our imagination at this point.
So let's end on that point. Lightning round, really quick answers here. What's the one thing that's going to surprise us when we get together again in 12 months for next year?
Probably much more advanced reasoning and research models. I think one future thing is with all these reinforcement learning, maybe these deep scientists, maybe there might be some breakthrough that AI might be able to do its own research. And then it's one step closer to
I like that one, actually, yeah. AI-driven research, not researcher-driven research. Go ahead.
I think for me, it's going to be kind of use cases broadening. I think, especially in the tech space, with Cursor and Claude Code, that has been a very kind of tip of the spear, in terms of things that are usable. I think we will start seeing that in other parts of the organization and other business units besides software engineering.
I predict, and maybe I hope, some new architecture of the models rather than transformers will bring a new set of models that will totally eclipse the current models that we have.
Fantastic. On that note, we're ending right on time, so thank you very much. Enjoy the coffee break.